Hello everyone, welcome to the channel. If you are a recurring visitor, welcome back. For this video, I'm going to go over object-oriented programming. And object-oriented programming gives us a lot of features and a lot of ways to design our software. Now, let's start off with the definition of OOP, or object-oriented programming. So object-oriented programming is just a paradigm for creating software around objects. It's just a way of programming. You do not have to design your software in OOP style. You can use procedural. And if you want to design your software procedural way or procedural style, you can use a software like C. But if you want to use OOP, you can use languages like Python, Java, C++, and more, right? So object-oriented programming is just a style or a way of programming. Now, OOP have 6 pillars. Some people may say OOP only have 4 pillars, but to me, OOP and to a lot of other developers, OOP stand on 6 pillars: class, objects, abstraction, encapsulation, inheritance, and polymorphism. I'm going to go through each of them with examples and in depth. Now, let's say you want to build a toy, or you want to build a figure using Legos, right? Each pieces of Lego going to be an object. So you want each piece to do something differently. And then you're going to bring all the objects together to make a bigger project or a bigger figure. Each object perform a different task. When you are when you're using procedural language like C, you're going to use functions. So each function will perform a different task. But with OOP, each object will perform something differently. And we're going to bring all these objects together to create a bigger project. Let's look at this other example. In OOP, first you have to create a blueprint. What do you want? Okay, what do you want to accomplish at the end? What do you want the software to do at the end? So a blueprint is a detailed technical plan or guide for creating something complex. The blueprint in OOP will be your class. You're going to design your class, right? And we're going to see an example of that soon. Then from the blueprint or from the class, you're going to create objects. And then the program is when you combine the pieces to build something bigger or to complete your software or whatever you was trying to accomplish. Now, OOP helps you build programs that are easier to understand. So you don't have to go through long lines of code to understand what the program is about or what the program should do, right? If you break down your program into objects or smaller pieces, you would quickly understand what the program is about. OOP helps with maintenance. When you are maintaining programs that are created object-oriented style, it's easy to go in there and maintain whatever pieces that you need to maintain instead of maintaining the whole program or a long list of codes. Okay, so if we go back to the previous diagram, let's say something is wrong with the pink object and it's affecting the other pieces around it, right? So the program is not running properly. You can go right to the pink object and maintain that piece of code instead of going through the long list. For example, if you're in C, instead of going through a long list of code just to find where the error is at, right? So that's part of maintenance with OOP. Now, the next thing is OOP allows reusability. You can reuse your code in different places. Then we have expand. You can expand from the pieces of objects instead of starting all over. So these are the things that you can get done, or OOP gives you that upper hand when it comes to software creation. Now, let's go back to objects. As we said before, objects is something created from a class. So each of the objects here, the red car and the blue car, they will both have a start function and a stop function. When you're creating a software, you don't want to keep writing over the same code, repeating yourself. There is this thing in programming that says, do not repeat yourself. Dry programming. So try your best to not write repetitive code. So class will give you that. If you know every car will have a start and stop function, they will have wheels, they will have tires. These are things you put in the blueprint, and from that blueprint you can give it to every car, because every car must have these functions. You do not want to write over new codes for each new car you're going to produce. Okay, so this is how objects look in C++. This is how objects look in Python. This is how object looks in Java. This is how objects looked in C#. Now, C# is a little bit different. C# uses the new keyword, right? And in C++, when you use the new keyword, we're talking about dynamic programming. Okay, we're going to get to that in a different video. So let's keep going. First, we looked at object, and I said that an object is created from a class. Now let's look at what is a class. So a class is a blueprint in OOP that defines what an object is and what it should do. Let's look at an example of a class. So let's take a car company, for example. Let's use Toyota as an example. Let's say Toyota, they want to create their new cars for 2027. The first thing that they have to do is create a blueprint, how they want their car to look before they start building the car. Now, everyone knows that a car must have a brand, model, year. It must have tires, it must have front windows. And then each car must have a start and stop function, right? Also an accelerate function. But we're just going to use start and stop. Keep it very simple. So before the company creates the car, they should have a blueprint. And that's what a class does in software development or in OOP. So here is how you create a class in C++. First, you have to define the name of your class. So the name of the class will be car. Then you have your properties in the car. Your properties are variables, and these are the brand, the model, the year, and the colors, and so forth, right? Everything you know that a car should have, it should be in the class. Then you're going to define the functions of the car. So the functions or the methods will be start, stop, accelerate, reverse. So these are going to be the functions, the things that makes the car move. Now, when you define your class, from the class you will create objects. Okay, my car is an object. Now, when you create that object, then you can go ahead and name your car and give your car some special features, right? So the brand will be Toyota, the model will be Corolla, the year will be 2020, right? And then you're going to have your start and your stop function for my car. Okay, let's say I want to create your car or my friend's car. Then I would say car, my friend's car. The brand will still be Toyota. The model will probably be different. Maybe she wanted Toyota Corolla hatchback, maybe she wants a XE or some type of brand, right? Upgrade. She wants to upgrade her car, so her brand will be different from mine, right? So that's what object-oriented programming style gives you. If you were programming or creating that software using C, you wouldn't really have that. You wouldn't really have that way of programming. However, you can use structures. But structures is a little bit different from classes. Now, this is how you would program that in C++. This is how you would program this in Python. Now, as you can see, Python is a little bit different from C++, but the concept and the logic is the same. This is how you program it in Java. Now, if we look at Java code and C++ code, it's quite similar. Instead of int main, it's going to be public static void. Okay. And then this is how you would program it in C#. So in OOP, you have something called abstraction. And abstraction means to hide unnecessary details and only show what's important. So for example, okay, let's say you're working at the manufacturer and you're creating that car. The users doesn't have to know how inside of the engine work. The users doesn't have to know how the pistons work. The users doesn't have to know how the oil lubricate the parts of the car to keep it going, right? You hide all of those things underneath the hood. What you see is the important details, okay? You would see the car start. You would see the car stop. You would see the wheels turn. So abstraction helps you focus on what something does and not how it does it. It creates boundaries between external working of the system and the outside world. Now, this is how abstraction looks in C++. Now, if we pay a little bit close attention to the code, when you're using abstraction, it's going to be you need to have virtual functions, right? And if we look here, virtual functions, if it's equals 0, then it's going to be a pure virtual function. And I'm going to create another video for that as well that goes in depth with virtual functions. Now, you will need virtual functions to override each of the car's functionality. Okay, that's what the virtual function does. The virtual function just helps you to override the function's ability. So each function, like for example, when we have the virtual function for start, maybe some car can start up slow, maybe some car can start up hard. When you override a function, you give it its own functionality. So an electric car, you want it to start quiet. A gas car, you want it to start a little bit harder. You will hear when the engine starts. And both cars, they're going to use the same start function. Just one will start quiet, one will start hard. That's what overriding does. If we do not override the start function, when you creating your object, C++ will always call the start function. So if you make that start function to be soft, every car would have the soft function. But once we put virtual, we have to change the characteristics. This is how abstraction looks in Python. You can see it's much different from C++. You call the abstract method, and we import the abstract method from this imported file. This is how abstraction looks in Java. You say abstract class and you add your methods in your class. And here it says class Toyota, right? And it extends the car class. They use the term extend. Now, if we go back to C++ abstraction, here it says public instead of extend. Now, the public is just an access specifier. How can you access the car, right? You want to make it public, you want to make it private, or you want to make it protected. And then this is how you have it in C#, right? Void, public, abstract, void, and you also have an abstract class. And then you need the override keyword to override the functionalities. Now let's take a look at encapsulation. Encapsulation protects the data inside an object and only expose what is necessary. Now let's look at encapsulation as a pill, right? You have all of your data and methods inside, and we use that little capsule to protect your data and methods inside of that class. So Encapsulation protects data from accidental changes. It helps control how data is accessed or modified. It keeps code clean and organized. It prevents bugs caused by direct access, and it hides the complexity from the users. Now, why encapsulation matter? Let's look at it this way. You can start the car, but you cannot directly manipulate the engine pistons. You do not have access. Well, some mechanics have access to go in there and fix it, right? However, you, the driver, cannot directly go into the engine and manipulate how you want that pistons to work. That's what encapsulation does. It only shares what is necessary to the user. You may be thinking, well, encapsulation and abstraction kind of does the same thing. However, it doesn't. It may seem like it's doing the same function or it has the same functionality, but in reality, it does not. So let's take a look at it. Encapsulation wraps data and methods together, restricting access to protect the data. Okay, the key word here is data. We are hiding the data. Now, abstraction on the other hand, it hides unnecessary details and showing only what's important, meaning that the abstraction, you don't need to know how that car works, right? It hides the functionality of the car, whereas encapsulation only hides the data. So abstraction is more for real world example than encapsulation. Encapsulation is more for your data or properties or variables, right? If you have to code such thing, this is how you will code it in C++. So we have class car, we have our private string, which is for color. So you cannot directly access the color variable inside of your class. You would have to use a function to get it. So the function get color will go ahead and get the color that is inside of your class because the variable is private. So you would have to use a public method, which is called the get method and the set method. In C++, we call it getters and setters. So the getters or the get function will get the color of the car because it is private. And then when the get function get it, the set function will set the color of the car. So it will store that information. So here it's setting the color that it's get. It's passing through the parameter. And then we're going to set it to the color that is inside of the class. Sometimes in C++ you will see this dot color. The this keyword helps us a little bit in C++. So sometimes you will see this dot color, and this dot means the color that is inside of the class or the variable that is inside of the class, right? So this is how it looks in C++. This is how it looks in Python. Python uses self instead of this, right? Python uses self dot color, so underscore color, and in C++ it use this dot color, but it's not necessary to use the this dot color. The only reason you would want to use this dot color if you want to differentiate, let's say inside of the parameter we have string color. So both of them have the same name. So then you will say this dot color equals to color what passed through the parameter. But if the variable is different, then you don't really need to use this dot color, right? C++ is smart enough to pick up which color that the user is talking about. If we look at Java, Java also have the set and get method to access the color that is private in the class. Now, if we look at the set method, Java also uses the this keyword. In the parameter, the color is the exact same spelling as the color inside of the class that is private. Now, if someone is reading the code, they would want to know which color is it referencing. So the this dot color is referencing the color that is private, that is inside of the class, and then the color is the color that is coming through the parameter from the set method. And then we have C#. C# also have a get and set methods as well. Now let's take a look at inheritance. Inheritance lets you build new class from existing class. It lets one class, which is the child class, reuse the properties and behavior of another class, which is the parent class. The parent class is always the base class, or the base class is the parent class, and the derived class is the child class. Now, why inheritance? Why do we need inheritance in OOP? Inheritance avoid repeating code. So for example, let's say you have mom and dad. Okay, you're going to inherit some features from your mom and your dad, and you are going to have your own features as well. Okay, so that's what inheritance does, right? We're not going to give you your own DNA separate from your mom and your dad. You're going to inherit that from them. Then you're going to have your own characteristic as well. Okay, so going back to the car example, each car is going to inherit properties or characteristic from the base car, the first model, the very basic car. And then every object that you create, they're going to have, or every other car you create from that is going to have their own characteristic. They're going to have their own VIN number. They're going to have their own color. They're going to have their own speed, right? Engine size. So that's what inheritance does. Inheritance lets you inherit things from the base class, and then you just add your spices to each of the object. Now, inheritance also make program easier to maintain, right? So if anything happened to, let's say, the inherited class, you only have to go back and fix what you put into that inherited class. So if anything happened to that car we created from the base class, we go directly to that car and fix that car instead of going back into the base class and fix it from there. So inheritance make programs easier to maintain. It also helps organize class in logical hierarchy. So the parent comes first, and under you would have the child, and then the grandchild, and you go down from there. All right, same as you have the base car. Every car start off with the base, and then you go when you come down the hierarchy, this car will probably have a bigger engine. This car will probably have more cylinders. This car will take premium gas. This car will take regular gas. And lastly, inheritance lets you extend or customize behavior. Just as the example I just gave, you can extend on inheriting things from the base class. Now, this is how inheritance look in C++. So we have the car class still, and we have some public method start, right? Start is our method. Then we're going to have an electric car. So this is going to be the regular gas car, and this is going to be our electric car. Now, the electric car will inherit whatever the base class have, or the base car have. It inherit the start function from the base class. Now, when you are inheriting, right, if you are inheriting from a class, you have to have the access specifiers. And as I said previously, the access specifier in C++ is public, private, and protected. And this is how it will look in Python. This is how it will look in Java. And this is how it will look in C#. Now let's take a look at polymorphism. Polymorphism literally means many forms. So it means the same function or method name can behave differently depending on the object that calls it. So let's take a look at this example. Let's say all of this car have a start function or a accelerate function. Okay, when you start the car, you press gas, each of them have a function that when you press the gas, the car is going to take off, right? It's going to accelerate. Now, let's say the orange car may take off faster than the green car. The red car may take off louder than the orange car. The black car may take off faster but less quieter than the red car. And then the white car may just take off a little bit faster than the red car, but it's going to be quieter. Hopefully I explained it right. So each of them with polymorphism, the function, the accelerate function, they all going to inherit it. However, each of them takeoff will be different, right? One may take off faster than the other. One may take off louder than the other. One may take off quieter than the others. So that's how polymorphism works in C++. It literally means many forms, right? So if I call the accelerate function based on the object that calls it, so if let's say the BMW calls the accelerate function, it will take off differently. If the Ferrari calls the accelerate function, it will behave differently. That's what polymorphism means. So this is how polymorphism looks in C++. This is how polymorphism looks in Python, Java, and C#. Now, these were the 6 pillars behind object-oriented programming. Once you get the grasp or the concept of how OOP works, when it's time for you to write your code or design any software, or if you go in and work for a company doing software development, you would know how to write proper code, right? And proper code, clean code is always the best way for writing code. You're trying to get hired into a company, you have to know how to write proper clean code. So this is all for this video. Hopefully you guys learned something, and your like, subscribe, share, that's what keeps me going. So please don't forget to do these things, and I will see you in the next video.